using rational numbers and the coordinate plane. And we've been talking about the coordinate plane for a while now. The coordinate plane is just a fancy way to say a graph with all 4 quadrants. Okay? Here's a little thing about it before we get started. A part worker has to use all 22 feet of board to make a square sandbox. Pause. When you're reading the directions on some of these questions, I've noticed that we're not really reading them very carefully to figure out what the question is giving us. Okay? So some important information, some important words that we see in this first sentence is she has to use all 22 feet of board to make a square sandbox. She tries, but all she can come up with is this plan as shown. Tell what she got wrong and right, and then show a plan that does work. Include coordinates for your plan. So, we're going to work this one out together. As you can see, what she came up with is not a square. One of the sides are 6 feet long, but the top is only 5 feet, and the bottom is only 5 feet. Okay? We have to make this a square sandbox, and we have to make it, or use all 22 feet of board. We know that when we have a square, we have to cut all boards into 4 equal lengths. Right now, they're not equal. We have 2 lengths of 6 and 2 lengths of 5. What lengths do we have to take away from the lengths of 6 and add to the 5s in order to make it even? That's what you have to think about when solving this problem. So, what if we took half of 1 away from 6? We do it 5 1/2. Which would be right about here. And what if we took that half that we took away from the 6 and added it over here? That would add half to the side. Okay? So I want you to go ahead and copy down this important information. If you didn't get all the information from the last slide, I would go ahead and copy that one down as well. So what we're talking about overall today is what polygons are and how we would use those on a coordinate plane. A polygon is a closed figure that is formed by 3 or more line segments. They do not cross. So once they meet, they stop. So again, important words. A polygon is a closed figure that is formed by 3 or more line segments, and they do not cross. Here are 2 examples of what a polygon is. You can copy down these examples along with the definition, or you can create your own examples based on what we have here. Okay, you know it has to be a closed shape. You know the lines have to be straight. All right? We are also given a couple of examples of shapes that are not polygons. So this right here is not a polygon because it is not a closed shape. It was like this. Okay? Why is this one not a polygon? That's a closed shape. If you're not sure, read the definition one more time. It says a polygon is a closed figure formed by 3 or more line segments. What? Stop. Line segments is the next important word. This right here is not a line segment. Okay? A vertex of a polygon is any point where 2 sides of the polygon meet. A vertex is just a simple, math way to say corner. Corner, vertex, vertex, corner, vertex, 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 vertex. Okay? All a vertex is basically a corner where 2 line segments meet, just like a wall. Okay? There's a corner in the wall. Remember when you were in K-5 and your mom made you stand in the corner if you got in trouble? That's what we're talking about here. Okay, copy this information down and then push play whenever you feel like you got everything down. Okay, so here is our think about it for today. I want you to move along with me. I'm going to plot these 3 points and then create a polygon. Follow along on your whiteboard and make sure that you understand how to do this as well, because you will have some independent work and it'll be on the homework as well. Okay? First things first, we know that when we're looking at an ordered pair, the first number is always your x coordinate and the second number is always your y coordinate. So we always plot x before y, and the best way to remember this is x comes first in the alphabet. Okay? So we have -3.5. That means we have to go to -3 and then go halfway between -3 and -4. Okay? We are not done. Now we have to figure out where the y would intersect. Go down 1. So we end up about right here. And remember, when you're plotting points, a way to keep track of what you're doing is to label it. So A is done. B. This one's going to be really easy. I know a lot of you guys are really good at plotting whole numbers. So X is first. 1, 2. And then Y. 1, 2, 3, 4. Okay. This is E. And last we have C. Again, X before Y. We have a +4, so all the way over here. And then we have a -3. We're going to go down 3. Okay, remember Y is up and down. So now we're right here. Okay, that's not a very good circle. Now all we have to do is connect our points, which will be turned into our vertices, to create a polygon. So I'm going to go as straight as I can. I'm on the whiteboard, so it's not horrible. Now we have a polygon, and now we have 3 vertices. Okay? Hopefully that's kind of clear. If you feel like you didn't understand that, you can just go back and push pause and copy down what you saw, or watch it again. Okay? Sometimes repetition is really helpful. Now after this one. All right, find the length of segment AB and segment CD. So let's look at AB first. Okay? That's going to be the easiest thing to do, guys. Just take it one step at a time, because if you look at the whole thing, sometimes it can be a little overwhelming. So we're trying to figure out the distance from here to here. You can count it by ones, which would be kind of hard because A is not really on a 1. Or you can find each distance. So let's figure out what the distance is for B. Starting at your origin, B is 1, 2, 3, 4 spaces away from 0. Erase this real quick. Okay? So we have 4. A is on the opposite side of the y-axis. This is the negative side. We're going -1 and a half to line up with A. We know that when we're talking about distance, the negative numbers are never negative, because you don't say, he's just like a -1.5 feet away from me. You would just say he's 1.5 feet away from you. So all you're going to do is you're going to add 1 1/2 to 4 to figure out the total length of this number. Okay, add your whole numbers. Well, we have 5 and 1/2. So side AB is 5 and 1/2 units wide. Okay? Now we are not done. We were just going to take it one step at a time, remember? So now we have to find the length of side CD. Okay? C and D are both on the positive side. So we won't have to add our 2 lengths together, because you're just trying to find from here to here. okay? What is D located from the origin? Well, D is only a half of a point away. All right? And then C is at 1, 2, 3.5. If you were trying to figure out what the distance is from 1/2 to 3.5, what would you come up with? Think of it kind of like this. If you were trying to find the distance between 1, between 1 and 3 on the number line, you would just think about it like this. Well, the distance between 1 and 3 is 2 units. Okay? Just 2 units. So you're going to do kind of the same thing here. What's the difference between 1/2 and 3.5? And guys, that's just going to be 3 units. Because you're just going to take away that extra half. If you're going to 3.5 and you're taking this length away right here, you would just get 3. Okay? So this length here is 3 units. All right, let's move on. Let's run out of time. All right, I want you to solve this one in your notebook. You're going to try to find the length of side BC. When you figure out the answer, I want you to raise your hand and have a teacher come check it to see if you got it correct. All right, I want you to create a coordinate plane in your notebook. You can use some graph paper on the back, or you can use your own, or you can just create your own coordinate plane using a ruler, okay? Use the ordered pairs, A, B, C, D, and E, to draw a picture of home plate in a baseball. Now, I had some kids just randomly draw a home plate. That's not the directions. You have to find these coordinates, okay? So A, you have -8 1/2 and +8.5. So, we're going to go past the -8 on the x-axis, and as you can see here, they're counting by 2s. 2, 4, 6, 8.5. And then we're going to go up 8.5. 2, 4, 6, 8.5. So you should be about right here for your first point. Okay? Second point. Well, that's a really bad check. B, -8.5 and 0. Okay? So we're going to go down, -8.5, like we just did, and 0, which means we don't go up or down for the line. We stay on the line. All right, so B is done. C is at 0, which means we don't go left or right on the x-axis, but it is going down 8.5, 4, 6, 8.5. All right. D, +8.5 and 0. And E, 8.5, 8.5. Now just connect your lines to create a polygon. Ta-da! There's the home plate. Okay? Let's check that away. All right, real quick. For our home plate, each unit is going to be 1 inch apart. You're trying to figure out the length of the home plate because you want to make sure the area, whenever you're creating your ball field, is big enough and it works, okay? So from one side, it's -8.5 inches from your origin, and the other side is +8.5 inches from origin. What is the length of the front of your plate? Pause the video and see if you can figure it out. When you figure it out, check with the teacher to make sure you got it right, okay? All right, to close it out, what makes a figure a polygon? Why might you draw a polygon in a coordinate plane? So I want you to think this through, work with your neighbor if you need to, and have a great day. Get started on your digits.